Hello, everyone. My name is Justine. I'm a 50 PhD candidate uh, in environmental economics at the University of New Hampshire. My research cuts across sustainability and conservation of lives on land and water bodies, which I believe are connected to these three SDG goals. Also, I am a fellow of the Sustainability Institute of University of New Hampshire, and I'm working with Revision Energy on data modeling to inform EV charging across New England. So Revision Energy deals with heat pumps, solar panels, and installation of EV chargers, which is the project I'm working directly on. And this project is connected to these two SDG goals. What if I told you that the ISO New England predicted that the usage of EVs in the region is going to blow up to about 300% in the next 10 years? So that simply means we need more EV chargers, more investments, more investors. But if there is anything an investor cares about is the return on investment. So my company has been modeling EV charging infrastructure, the processes and all the mechanism to understand deeper how this investment can be attractive to investors. The aim is to realize the projected widespread of EV usage in the region. It's a complex process. However, this summer we narrowed down on a couple of important key areas that we believe affect returns on this investment. Using real life data, I was able to model and predict EV charging patterns in terms of how many users, utilization rate, period of use, and duration. So understanding this space will give us insight into the kilowatts per hour and the peak power, which are really important to an investor. So I use data from 4 charging locations with over 3,500 data points. And what I found, what I call the existing condition of DCFC, that's DC fast chargers. So as you can see, utilization rate, we have the time utilization up to 22%, which is quite high. However, the power utilization rate is very low. So think about this concept as a store. People walk into a store, but it's not. But what matters most is those that actually bought items from the store. So the time utilization is like people walking into the store. While power utilization is more of those that bought items from the store, which is very important when you talk about returns on investment. Also, I looked at the time period of use, how it varies in terms of duration and energy generation, as well as number of usage. You can see there isn't much variations in duration and energy in the 3 different periods. However, the number of users, we have a lot of variations where the off-peak period recorded the lowest number of users. In conclusion, the analysis I showed you and more, data-driven pattern, and of course, reveals difference in charging behavior. These have implications to investment in EV charger, as well as data-driven decision-making. Now, going forward, I feel like more robust data will be needed to have more comprehensive analysis. This project has made me to learn a lot about EV chargers and improve my analytical skills. I give my shout out to my mentor, Chuck, as well as the entire EV team at the Revision Energy. Thank you for listening.